And we are ready to go. So for this particular one, we're going to be talking about 9.2. Hopefully you went back and kind of reviewed my video that I made for 9.1. It says section 9.1 slides and video lecture. This is a good one to will help with this section also. But I think this is pretty much self-explanatory as far as this video. And this one is 9.2 kind of does a little bit more in detail. So this is where I need to kind of make sure I go in and kind of do more like talking about it. So let me hit present. So for this one here, we're going to be using what is called the elimination method. They're all in 9.1. They have another method called substitution method, but it's not really recommended because it'll take a long time for you to do a three system equation. So basically what the elimination method is, it's just if you think about the word elimination, we're just trying to eliminate a letter, a variable, to make the problem a little easier so we can solve for x, solve for y, and solve for z. The most important thing that you need to do, especially when we start these threes, is you need to label each one of these questions. This is question one, this is equation one, this is equation two, and equation three. And as we create more, we're going to create more equations. So we'll name that one 4, we'll name that one 5, and so forth. So for this one here, what we're trying to do, if I look at this equation, I'm going to start off, and again, I'm going to probably say this and repeat this many times, but it does not matter which two equations you decide to go ahead and eliminate first. It doesn't really matter. I'm just going to stay consistent with these slides and go ahead and eliminate the first letter here. So if I look here, I'm going to take equation 1. So this is where I get equation 1 and multiply by 4. So you might ask, why am I multiplying every part here by -4? Well, if I want to eliminate the x's, don't you agree? If I had a negative and a positive, won't they just cancel out? This is what we see here. So take this first equation here and we multiply by -4. So this one will be -4x. This one will be positive. Two negatives make a positive, 8y. And then we multiply this one by -4 and get -12. Also, you multiply this one 11 by the -4 and we get -44. And then we don't really have to do anything to the second one but write it over again, because I look now, if I add these two, now it does not matter. I know in 9.1 I said it's always best to add. You can subtract the equations too, it doesn't matter, but just pick one, addition or subtraction, to make sure some letter gets eliminated. So if I add these two together and negative, they go away. 8 plus 2 is 10. -12 plus a -3 gives -15. And then you add these two together, -40. So this will be now our new equation 4. I just eliminated the x's and I'm just left with now y and z. So now we got to go back up into our original equations and choose two different ones to come together to eliminate here. Now, since we eliminate the x's, we must stay consistent and eliminate those x's also. So with this one here, if we look at equation 1 and equation 3, and if I want to eliminate the x's, if I multiply the equation 3 by -3 for each one of these, then the x's should cancel out also, leaving me just, again, the y and the z. So let's kind of see what that looks like. So multiplying the equation 1 by -3, and I'll go back so you can see. -3 times this gives us -3x. This gives us going to be a positive 6. And then -3 times 9, I'm sorry, -3 times positive 3 gives us a -9. And then 11 times the -3 gives us a -33. So this is where we got these parts here. And again, I don't have to do anything to the third equation. I just recopy it because, again, we're trying to eliminate the x's first. So here, if we add these two together, you see how the x's do cancel out, and what letters are we left with now? Y and z, just like we did here. That's our goal when we're trying to start off these problems. We want to try to eliminate one of the letters so we can left with two letters left so we can finish off the problem. So we name this equation 5 now. So this is my original equation from 1, and here are my two new equations, 4 and 5. Now looking at these equations here, what letter do you think we're going to eliminate now? Because now we have to get down to when we have only one variable that we're solving for. We can't solve for y and z at the same time. So we have to do the elimination process again with our two new equations, like so, to get down to one letter. Like I said, you can eliminate the z's, it does not matter. You can eliminate the y's, it does not matter. For this particular one here, we're going to go ahead and take the 4 and 5 and try to eliminate the y's together. So in order to do that, if I take this part here and multiply by 9, each part here, and then multiply this one by 10, do you agree that multiplying this by 9 and this by 10, it makes 90 and 90 as far as the y's? This is where I have here. So the top one, we multiply everything by -9. So right here, equation 4 by -9. And then we're going to add it to the new equation, which is equation 6. So these times the y's cancel out. And then we're taking both of these now, we add them together. So if you put in your calculator 135 plus a -100, we get +35. Add these two together, we get 70. And how do we solve for z? Take both sides and divide by what? The 35. So we do that, we get 2. So we actually did all that work to get one of our answers to be z equals 2. Now we need to figure out what y is. So we don't need to jump back to our original problem to figure out what y is. We can actually jump to either 4 or 5 to figure out what y is, because we know now that z is equal to 2. So it's up to you to either plug the z, put the 2 in for z here or here. It does not matter. You'll get the exact same answer for y by plugging into here or here. So for this case here, I chose equation 4. I'll plug the 2 in, the z that I got here. This gives me 30. I take the 30 over by adding, doing the opposite. I get -10. Take the 10 over by dividing both sides, and y should equal -1. So once again, just real quick, if I'm going too fast again, you can just take this video and just replay it to yourself over and over. But knowing here that I already solved for two letters, z equals 2, and then y equals -1. What is the last letter we need to solve for? That's going to be our x, right? So we finally substitute it back into the first equation. Once again, I'm sorry I keep repeating myself, but I just want to make sure we have that clear understanding. If we have the z, which is 2, and the y, which is -1, we can plug it into any one of these equations, 1, 2, or 3, and get the same answer for every single one for x. It's going to be the exact same answer. I'm going to choose 1 because if you look at equation 1, x is kind of already by itself. That makes the problem just a little bit easier when your coefficient is 1 and you're trying to solve for the last equation, because then you have to do an extra step by dividing by 4 or dividing by 3. So equation 1 looks the easiest one to plug in all my numbers in to figure out what this x should be. So let's do that real quick. So the -1 I'll plug in for y. I'll plug the 2 in for z. These two multiply together gives me 6. These two multiply together are negative, negative makes it +2. 2 plus 6 gives me 8. Take it over here by subtracting, doing the opposite, and that gives me 3. So in our final answer, we write x, y, and z. 3, -1, and 2. So this is pretty much the process of solving for elimination and what I just kind of laid out for this particular problem. This is a page that you can do in the book for practice purposes. Just open your book. Number 1 and number 2 are good practice problems to do. But here's another example. So once again, looking at here, my equation 1 is going to be this one. Equation 2 is this. Equation 3 is this. So again, I'm choosing to eliminate x first, but you are more than welcome to eliminate 2 z's or 2 y's. Again, it does not matter. for this particular one. So looking at this problem, what's the first two ones looks like it's going to be the easiest one to eliminate. I think this equation 1 and this equation 3 because they just have the x's together. So if I actually take equation 1 and subtract it from equation 3, wouldn't y'all agree this x minus this x, the x's actually go away? So that's what I'm going to do. Now this particular one, I subtracted them. If you want to distribute the negative inside, make this a negative, make that a positive, make this a negative, and make this a negative, you can do that and then add them together. Is exactly the same thing. Whatever you are more comfortable with, please do. We sit here, we get this equation. Remember what I asked you to do for every time you create a new equation. The new equations always come from when we add them together or subtract them together. Not when we change the numbers all in here, like distribute a negative or here. When we actually take two equations and add them together or subtract them, we create a new equation and we make that equation, we name it equation 4. So I'm left with just y and z. So now I take a new set of two equations. I'm going to take 2 and 3 this time. Now for 2 and 3, the x's just don't completely just go away by subtracting and add them. If I subtract them, I have an x. If I add them, I get 3x. So I need to multiply this x by something so these x's will cancel out. And it looks like if I take a 2 and multiply everything by 2 and subtract them, this times 2 gives us 2x. This here gives us -8. This 2 here gives us 2z. And then if I double 18, it gives us 36. So I took equation 3 multiplied by 2 and now subtract them. The x's you see cancel out. Y minus a -8 gives me this 9 here. And taking the -5 minus a 2, that gives us the 7 here. Subtract these two again, -21 minus 20, it gives us a 57. And it should be a -57, I think. Yeah, if I subtract them, yes, a +57, sorry. Negative. So for this one here, I have my new equation 4 that came from here, my equation 5 that came from here, and now it's time to eliminate another letter, either the y or the z. It don't matter in this case, but for this particular person, I'm going to actually eliminate the y's this time. So if I have this 6 and this 9, the only way to get them to eliminate is they have to be the same number. So if I multiply this one by 6, everything, so 6 times 6, 36, 6 times -3, -18, 6 times -33, -198. Take the bottom one, equation 5, and multiply this one by -4. We get this equation, and notice how the 36s now are the same, and we can now subtract them or add them, does not matter, to make sure they eliminate. So the y's go away. We take these two, add them together, we get +10. Take these two, add them together, I get 30. How do we solve for z? We take the 10 over this side and divide, and we get z equals 3. Yay, we got one letter. So now we got to go back and get y and go back and get x now. So once again, take this z and go back to equation 4 and 5. So this is my equation 4 and 5. You don't need to plug z into these equations because these are our new makeshift equations that we multiply 6 and -4 to. So we don't plug it back in here. Plug it back into when we got originally the 4 and 5. So we'll take this 3, plug it into one of these equations of your choosing to figure out what the y is. So for this one here, I chose 4. Take this 3, multiply it by this 3 here, and do you agree that -3 times this 3 gives us this 9 here? Take this 9 over by doing the opposite, which is addition. It gives us -24. Take this 6 over by dividing, and we get y equals -4. So now we got two letters that we solved for. Z equals 3 and y equals 4. One more letter that we need to solve for. So looking back in our original ones, what do you think which one we should plug those the x and the y, not the x, the y and the z into? The first one or the third one or the second one? It does not matter, but whatever one you see fit to see like looks to be the easiest one to plug it in, please do so. I chose equation 1. So we take our answer for 4, plug it in for y, take our answer for 3, plug it in for z. We do all the math, times these together, we get times these together, combine like terms, we get negative 14. Bring the 14 over by adding, we get negative 1. So if you can already see, and this is what the answer should look like, negative 1, negative 4, and 3. So obviously the frustrating part about this problem is, yes, there are a lot of steps. And if you did all this work to start with and get z's equal to, I don't know, maybe negative 5, and then plug negative 5 into it and get a different answer here and different, the whole answer gets thrown off. So you have to be careful with your addition, your multiplying in, distributing, and everything like that, because it's going to be very difficult to work these problems out, and it can be very long in process. The best way to help if you keep getting the wrong answer is to take the problem on another sheet of paper and redo the problem without looking at what you did first. Half the time, sometimes we make simple little mistakes like 6 times 6 is 36, but we add 6 to this 3 and maybe get 9 or a 3 or something and put 3 here, and that throws off everything here. Just that one tiny little mistake. So if you actually take another sheet of paper, work this problem out again, hopefully you'll catch this time that you actually supposed to multiply everything in instead of doing that one addition to throw the whole problem off. So here's another example I'm gonna go through again. I have it laid out over here what I'm gonna actually eliminate first. So I'm gonna do the first two, eliminate those, and then I'm going to eliminate 1 and 3. If you are watching this video over again, it'll be a great process and a great learning experience if you actually pause it, work the problem out, and see if you actually get the same exact answer to the end. So for here, 1 and 2, if I do 1 and 2, and I want to do the x's, let me go back a little bit. If I want to do the x's, I have to actually multiply every part here in order for these x's to go away by negative 3. Negative 3 here, negative 3 here, negative 3 here, negative 3 here. And then that way, if I add them together, the x's will cancel out. So here are my equations I wrote again. By multiplying the first equation by negative 3, negative 3x, negative 3y minus negative z minus negative 21. Like I said, if you actually do this on another sheet of paper on your time, you can kind of see the layout of all the numbers. And then we take equation 2 and add them together. We notice that the x's cancel out, the y's become the y become negative 5y minus 2z equals to negative 18. So that's what happens when I actually take 1 and 2 and I got this equation before. The next thing I'm going to take is 1 and 3 now. 1 and 3. Now, since the x's are already the same, I don't really have to multiply by any number. I can just subtract them, and then that way this x cancels out with this x. But if I take 1 and 3, I create this equation number 5 now. And this is where I get 5y plus 2z equals to 18. Now we're ready to eliminate another next letter using a 4 and 5. But if you notice here, if I actually add the 4 and 5 together, don't y'all see that all the numbers actually cancel out? So if I add this to this, a negative 5 plus a 5, that goes away. Negative 2 plus a positive 2, that goes away. And then negative 18 plus 18, that also goes away. So what are we left with? 0 equals 0. So what do you mean by this answer when we get this answer? For this particular one, when you have 0 equals 0, the answer for this one is going to be infinite many solutions. That's what it's going to say on my MathFlash Plus. It's going to be a choice where you can put the answer to be infinite many solutions. This is where this side of the equal sign is equal to this side of the equal sign. And this can be 5 equals 5, 10 equals 10. It does not matter. When all the letters go away and they're equal to they're equal on both sides, we write infinite many solutions. The next thing I want you to write down is, once your answer is infinite many solutions, you need to write down more work, or you need to go further. So we don't just stop and just say the answer is infinite solutions. This is the only process when we get 0 equals 0 and the answer is infinite many solutions where we have to take an additional step to get to the answer. So that's the part that you need to star in your notes is I need to keep going. Make a note yourself. I need to keep going if the answer is infinite many solutions. Okay, so let's get the final answer when the answer is infinite many solutions. For this particular one here, it does not matter again. You can actually solve for y and get y by itself, or you can actually get z by itself. It does not matter. For this particular one, I'm going to get y by itself. I'm going to choose the equation 4 and get y by itself. So I'm going to move the 2z over to this side of the equation by adding. So I should have negative 18 plus 2z, and then take this 5 here and divide everything by negative 5 to each part. So once again, just to repeat, take the 2 over by adding. That's where I get this positive from. Minus 18. Take this negative 5 and divide it here and divide it here, and you can leave it as a fraction. So once I get what y is equal to, remember our answer has to be x, y, z. For our y answer, this is what we put for our whole answer in my MyFast Plus. Negative 2 over 5z plus 18 divided by 5 in this part here. The x is going to be the hardest one to actually get to next because we actually have to use the substitution method and substitute all of y into one of the equations to get what our x is. And I'll show you what this looks like in a minute. So equation 1, remember what equation 1 looks like, and I'll go back to show you. This is what equation 1 looks like. I'm going to take equation 1 and I'm going to plug in the y. So here, all this problem here, I got plugged in for y. And then now I'm going to solve for x because I want to plug it in for this x as my final answer. So if I do that, I combine like terms, negative 2 over 5 plus this understood 1 here creates a 3 over 5. And you can put this in your calculator. Make sure you put parentheses around it. And then we're going to take the 18 over 5, move it over here because they're both numbers, and subtract it, and I get 17 over 5. Then we're going to take the 3 over 5, and we're going to bring this over by also subtracting. And this is where we get the opposite, negative 3 over 5z plus 17 over 5. This is actually going to be where that x is equal to. So this equation goes for our y, this equation goes for our x, and z is just z for our final answer. So you put this equation, comma, this second equation for y, comma, and then write z. You know when just to write z because you'll see that every equation has the z in it. So if you actually went back and solved for y, for z, if I move this one over here and solve for z, then y would have been in all the answers for our final answer. So like I said, it does not matter. Once you show your work on the any assignments that you need to turn to me, I will know whether if you solve for y or z, it does not matter, but your final answer should look like this. Again, this is the only process when we have to take it a step further is when it says infinite many solutions. I have another example I want to show you on this here, so don't worry. But just to kind of give yourself a check, the reason why the answer is infinite many solutions is because no matter what we plug in, we're always going to get an answer. So if you chose z to be negative 1, then I'll get an answer. If you chose z to be 0, then I'm going to get an answer for x and y, and so forth. These are just random numbers I selected. It'll just be so many answers that you can get because whatever you plug in for z, you're going to get an answer here once you plug it in, and then here, and you get multiple answers. Back when we have our other answers, this is the only solution that's going to be the answer for this particular problem that we worked on here. There's no infinite amount of solutions. So once I plug these numbers in, that is it. There's no other set of numbers that's going to work for this particular equation that we worked. So that's why that's the difference between infinite many solutions and just one solution. So this is my one solution. And this problem here, once we finish working, will have infinite amount of solutions, and we represent it looking like this. So let me go through another equation. Oh, let me talk about yeah, this one here. Just so you'll know, I don't think I have one in this particular slide, but if you get to a equation where they don't equal each other, so I have 0 equals -5, then we call this no solution. With no solutions, you don't have to go any further. All you do is put no solution and you're done. And remember, infinite many solutions are what you have to take the next step on and try to solve and get the equations for your answers. But once again, if this side over here does not equal this side at your final stage, then we write no solution. So here's another example of infinite many solutions. Just to kind of go through it a little quicker, I'm going to take equation 1 and 2. So I took this equation 1 and 2, since they already perfectly set up for me to actually just go ahead and add together, because the x's actually go away. I don't need to multiply anything to anything because the x's automatically go away once I add these two equations together. So those cancel, add these two together, get 6, add these two together, get -6, add these here and get here. That's my equation 4. I need to pick another two set. I did 1 and 2 this time. So this time I'm actually going to do 2 and 3 this time. So if I look at 2 and 3, I can't just get rid of the x's. So I have to multiply this x by something so it can get rid of, to eliminate with this x. So if I multiply everything in here by 2, then you'll see that they will cancel out. So 2, multiply everything by 2 here. These cancel, add them together, add them together, add them together. Here's my equation here. So this is what my equation 4 looks like. And then equation 5 looks like this one. So now I'm ready to take equation 4 and 5 and try to eliminate either y and z. But I notice once I do that, if I multiply the equation 5 by -6, this here, so if I take this equation 5, multiply by -6, so -6y, that's where I got this from. Negative and a negative makes a +6. And a negative here with a -1 gives us a +6 here. I add them both together. That cancels, that cancels, that cancels. Guess what? 0 equals 0. Everything cancels. Again, this is where we say, I'm not done. I got to keep going. So we go back to our original 4 and 5 and just solve for a letter. For this case here, I'm going to solve in terms of y. So I'm going to move this z over and just solve for y. So I'll move the z over by adding. I'm going to have z -1. So take this z over by adding. I have z -1. That I got one of my answers here. Well, I already know my answer for the final answer is just going to be z. My y is going to be z -1. And now we got to figure out what x is going to be. I'm going to use the first equation because it seems, again, the coefficient is 1, which makes it a lot easier to solve. I'm going to plug this whole equation in, z -1, to this y right here. So this is what I did. For first, I moved this 4y over here. I moved the z over. And then now I plugged into the z -1 here. I distribute. This time here gives you 4z. This time here gives you -4. Collect like terms. X is equal to 5z. So our final answer is going to be x is equal to 5z. That's what I got here. Comma, y is equal to z -1. That's what I got here. Y equals to z -1. And then z is just z because you see it here and here. So infinite amount of solution is going to be a dependent solution with this part here. These are another ones. Those of you that still want some more practice with infinite amount of solutions and no solution problems, these are good practice problems to do in your book. A little side note, when you start section 9.3, it's going to say, I don't really know how to pronounce these words, but I'm not going to try. But anytime the directions has these as the directions, then we're just going to do some more practicing using the elimination method. Because again, you have to do this on the lab. I will show you in my next video. I don't know when I'm going to have another session like this, but maybe on Thursday. But I will show you how to use the calculator to get these exact same answers, like so. But for practice purposes and for the work that you need to show work for, you need to practice. So anytime it says this here is this is a great practice method for using the elimination method that we just went over. So just throw out any time, again, just the directions say this, just eliminate it and just do the elimination method. Now to word problems. Obviously, word problems, we have to actually create our three equations. So there is no one way of doing any of these word problems. You just have to read it sentence by sentence and try to create a word problem for it. A 1 ounce serving of coffee, energy drinks, and soda contains 226 milligrams of coffee. So using this first sentence, how can we create a sentence out of this? Coffee, energy drinks, and soda all contain and go up to 226. Coffee, energy drinks, soda, add them together, and we get 226. This will actually be my equation 1. So from the first sentence, I created my equation 1. Second sentence, let's create an equation 2. 1 serving of coffee. So coffee we designated to be already to be X. So that's probably one of the best things you want to do off to the side. Write down coffee is X, energy drink is Y, and Z should be soda, so you won't make that mistake when you're working your work of what letters goes with what soda or item that you're talking about. So coffee has 14 more caffeine than 2 servings of soda. If I have 2 servings of soda, I'm thinking that's going to be double, right? So coffee contains 14 more than 2 of the sodas. This is my equation 2. Last equation, 1 serving of energy contains 36 less caffeine than coffee and soda. So 1 energy drink contains both the coffee and the soda together, less than 36. So this time the less than gets minus on the back side. Don't put it in the front because a lot of us put 36 minus x plus z. That's wrong. It has to be less than, so that means we put it in the back. So this is my equation 2 and this is my equation 1. Before we get started with our elimination method, we need to actually group them and put them back to what we was originally looking at. Remember where all the letters were on this side and just numbers were on this side of the equation of the equal sign. So this one's good because I have all the letters good, but this one here, I need to bring this guy over here, leave the 14 here, and then bring the 36 over here. I'm sorry, leave the 36 over here and bring the x and the z over, and this is our 1, 2, 3 equation. So you go through the process here and doing the elimination method. These already kind of lays out what the answer should be once you do elimination. So x should be 92. I take 92 and plug it back in to figure out what z should be. 39. Take the 92 and the 39, plug it back into our first one. Looks like be the easiest one to do, and solve for a z. I'm sorry, solve for y. And get 95. So 39 plus 92 plus 95 gives us the 226 for this particular problem. These are also good practice problems to do. I think I listed some of them already, but these are good practice problems to do, and the odd is available for you to do in the back of the book, so you can check your answers that way.